Assalamualaikum and a very good afternoon I bid to the panel. My name is FAKHRI bin ZULKULNAIN. So today I would like to present my final year project's proposal which entitled Radio Frequency Welding Terminal Manipulating Mold in Switching Board Design, Fabrication and Testing. First, I would like to give many thanks to my final year project's supervisor which is TS Dr. Muhammad Fauzi bin Ismail. Without his foremost guidance and constant teachings, this project will most likely will have many flaws and no completion. To start my presentation, I will present about the project summary. Radio frequency welding is another name for the process known as dielectric welding. This project's main goal is to enhance the terminal switching system in dielectric welding, which now focuses more on the impact of attaching the tube to the blood bag than any other aspect of the process. The system that will be brought to the research is the two-phase welding system. The equipment formerly had a two-phase welding method with a switch. The result of the evaluation and testing indicate that the material is not suitable for the perfect welding. The result of the study to test the mold will inform the evaluation of the proper mechanical design and fabrication for the two-phase welding system. Starting with the design of the mechanical system for terminal switching, we moved on with the project. After the system's blueprint has been finalized, it will be put through its paces to ensure it works with the radio frequency welding machine and the rest of the mold components. Any flaws will be found with a few sample tests. For the introduction of the project, radio frequency welding or dielectric welding is obtained by subjecting thermoplastic substrate to high-frequency electric fields in order to heat them up and melt them. After clamping the pieces together, an electric field is applied via a set of electrodes. This clamping action continues until the joint has fully solidified. Today, radio frequency welding is used in a wide variety of economic and industrial settings. In the context of this project, our primary concern will be a piece of medical equipment known as a blood bag. As you can see below is the radio frequency welding machine. One of the components that makes up the radio frequency welding equipment is called the switching board. In the process of welding blood bags, there are two different kinds of welding, which is back body welding and tube pot welding. Back body welding use one-phase welding, while tube pot welding utilize two-phase welding. During the transition from phase 1 to phase 2, which is the process of moving from welding the back body into welding the tube pot, the switching terminal will be used. For the time being, the transition from phase 1 to phase 2 will be carried out manually through a change in the terminal in order to achieve a successful and error-free welding procedure. The previous project, the machine used the two-phase welding system with the switch. According to the findings of the testing and assessment, the material cannot be welded successfully and flawlessly. It is possible that this is because the power source doesn't provide enough juice to do any welding. For the literature review, the process of radio frequency welding involves the application of pressure in addition to the transmission of radio waves. The plastic dielectric properties cause the radio waves to have an alternating polarity as they pass through makes the polarized molecules in the polymer vibrate back and forth, which result in molecular level friction and heat. Michael J. Truton in 2008 stated that power, heating time, cooling time, weld depth, pressure, and platen temperature impact radio frequency welding. Type of material, thickness, area of weld, necessary heating time, seam length, and barrier material influence the power needed to be welded. Welding tooling penetrates component by weld depth. Attention is needed for plain seam welding. The outcomes of the previous research indicate that changing the phases will be as simple as flipping a switch. A problem in the project is that it requires frequent inspection of the status of the wire connection. It is vital that the wire be properly connected to the connectors in order to avoid sparks which might potentially cause harm to the machine as well as to humans. Before the system can be put into use, it must first be put through rigorous testing to verify that it is secure once it has been combined with the numerous modules that make up the radio frequency welding machine. There was another challenge in handling the operating an RF welding machine so that a blood bag product could be properly aligned on the mold. Another problem also is the presence of a radio frequency welder cannot optimize the rod terminal weld mechanism. Failure to deliver adequate pressure at the bonded spot would fault the product. For the problem of this project, according to the prior research, switching phases will be as easy as turning a knob. In order to connect the numerous components of this project to the terminal switch system and the radio frequency welding equipment, copper wire was used. The project is flawed since it requires regular monitoring of the wire connection. To prevent sparks that might cause damage to the machine or to the people, it is essential that ensure the wire is tightly connected to the terminal, such as screws. When all the pieces of the radio frequency welding machine system have been put together, it is time to test them to make sure they are safe to use. For the objective, there are three objectives. The first one is to design of the parts for the two-phase welding system. The second objective is to design the mechanical system for terminal switching by the necessary components and put it all together. The third objective is to assess the design in light of findings of a mold test. For the scope and limitation of the project, the study has to be carried out using the design specification that have been provided by the client, and there was only one standard blood bag size and type used in the investigation. It is therefore necessary to verify that the component's fabrication design is suitable for use with the available semi-automatic radio frequency welding equipment. The system's 3D manufacturing layout will be designed using a CAD application. For the methodology, as you can see, shown are the project's flowchart. The process will start by performing research and literature review. There is the research that needs to be done in regard to the terminal switching. The purpose of this research is to amass information pertaining to this kind of welding and to make more strides toward the general objective of comprehending the method of radio frequency welding in particular. For the design, matching and calibration, the terminal switching system need to have some concepts of the conceptual designs that have been considered for it. During the research, copper plate is more effective conductor compared to the copper wire. Connect the electrical system by means of the copper plate, then screw it into place until it is as tight as possible. Calibration is necessary for every portion of the RF welding machine that has been improved in order to guarantee that the parts are compatible with one another and perform as intended. For the finalized the design system, after ensuring that the design takes into account all conceptual design, the final enhanced system design must be established in order to accomplish the goal of this research. Using computer-aided software, design the most effective system as possible, taking into consideration the findings of the study and the fact that the primary focus of the project is the existing radio frequency welding equipment. For the fabrication of the design, the project proceeds with the fabrication, which is essential to consider the workpiece to setup tool. Connect the wiring system using the copper plate, and tighten by the screw. For the rod connector part, the material used is steel and the machine used is involving the turning process using the lathe machine. For the perform and test and analyzing process result, after the fabrication has been carried out to its conclusion, the weld test will be carried out in order to evaluate whether or not the new design is performing as intended and to check the quality of the welding. The method of the test is to utilize the other terminal switching system to solder the medical tube to the blood bag in order to finish the connection. As an expected result of my investigation and analysis of the issues, I have developed a concept for the layout of the terminal switching system. After giving it some thought, I came to the conclusion that the best place to begin is with the circuit straightforward and well-organized connection. All of the bottom elements, including the bottom plate, top plate, mold, rod holder, are connected with the copper plate, and the connection among the rod is with a steel, which is a conductor at the rod holder, while a copper wire is used to connect all of the rod to a plate. When compared to the previous project, the new terminal switching system will be simpler to use. The circuit connection will be neater and it will not do any damage to the person who is using the radio frequency machine. That's all from me. Thank you.